Hello students, welcome to Automata Theory and Computability. So in this video, we will see about the design of deterministic finite state machine. So what are the different steps we have in designing the DFSM are? First thing, you have to identify the minimum string. So let us say whatever question they have given accordingly, we will have to first identify what is the minimum string we can form among those input alphabets. And the second one is identify the alphabets. Of course, in the question they would have given, okay, what are the input alphabets? So you need to identify them. The third step is you have to construct a skeleton DFSM. So skeleton DFSM in the sense you must have identified the minimum string. Accordingly, you know what are the input alphabets also. So according to that, we will be designing a DFSM pertaining to the minimum string. Okay. Now after that, in the fourth step, we need to identify the other transitions which are not defined in step 3. So once we find all other transitions, we need to complete the DFSM. So these are the steps in designing the DFSM. Okay. So let's go with the first question. The first question is like this. Draw a DFSM to accept strings of A's having at least one A. That means minimum one A I should have as a string here. Okay. So the first let us see what are some valid strings and some of the invalid strings. Okay. So the valid strings are, let's say it should have at least one A, right? So in the first one, I will try to give always the minimum string. So it is A, okay, at least one A. So one A I have written, and next I have written so many A's, and in the third example, I have written 2A. So minimum 1A I have. So they're all valid strings. Okay. So let us see some invalid examples. You know, the first one is epsilon. Epsilon means empty string. Okay. See, the question is you have to have minimum 1A here. Okay. So epsilon cannot be accepted. Okay. So the second example is B angle. Okay. You should have minimum 1A. Okay. I don't find A anywhere here. And the second thing is that this is consisting of strings of A's. There is no concept of B here. That means your input alphabet is only A. There is no B here. So this is also an invalid string. And look at the third example carefully. I have A here, but it's a capital letter, uppercase letter A. Okay, so what happens is uppercase A, we don't have it here. That is one point. The second point, again, the input alphabet B also, we don't have in this question. So this is also one invalid string. Okay, so you know what are some valid examples and invalid examples. Now we will apply those methods and try to design the DFSM. Okay, so what is the procedure we have is we have to first find the minimum string. We have to first identify the minimum string. So according to the question, it is given draw a DFSM to accept strings of A's having at least one A. So my minimum string is A. Okay. Second one is you need to identify what are the input alphabets. So according to the question, again sigma will be having only one input symbol, that is A. Now we need to draw the skeleton DFSM. So skeleton DFSM means we will have one start state, and then according to whatever inputs given, we need to reach the final state. Okay, so how do you write that? See, according to this one, once I read 1A, it should reach the final state. So I will begin with the start state. Upon reading 1A, I will reach the final state. Correct? So we have start state. Upon reading A, it will reach the final state. It's a very simple thing, what we have here. Okay, so this is what we call it as skeleton DFSM. We call it as skeleton DFSM because other transitions we are not using them here, or we are not designing all the different transitions here. We are just designing only the skeleton DFSM according to the minimum string. That's all. We just see that the minimum string constraint is satisfied here. So after this, we need to find out what are the other possible transitions. Okay. So The fourth step is you need to identify the transitions which are not defined in step 3. So what are the different other transitions means? See, the question is you have to design DFSM, right? You know what is DFSM? I have a state. Upon that state, from that state, upon every input alphabet, I should reach a state. I should reach either the same state or a different state. That means what? In DFSM, for every input symbol, upon every state, there must be a transition. Okay, that means I have two states here. One is Q naught, and what is the input alphabet we have? A. So what is Q naught upon A? We have to find out. Or if at all it is found, good, no problem. Then I don't have any other input alphabet, so I will start with Q naught. Then next state we have is Q1. So again Q1 upon A we have to find out. That means every state we should have a transition upon every input alphabet. Okay. Now, according to the skeleton diagram, we have Q naught upon A done. Okay. But now we need to find out what is Q1 upon A. Q1 upon A. Okay. Now look at the question. What is the question given? It is given to accept strings of A's having at least one A. Okay, one minimum one A I should have, but I can have later any number of A's. So in DFSM, any number of A's is represented using self loop. Okay, it is known as self loop. That means self loop means it can accept zero or more number of inputs. Okay, so let us just try drawing it. So we have start state, then from start state Q naught, upon reading one input alphabet, it has reached the final state. Now Q1 upon A. Okay, so what is Q1 upon A? Always, guys, you have to try these things. First, you check whether self loop is possible. Okay, self loop means zero or more number of input alphabets. If at all self loop is not possible, try going in the forward direction of the transition. Otherwise, try with the backward direction of the transition. Okay, that we will see later again in different examples. Now, for this example, let us try putting a self loop now. Okay, so when I put a self loop like this upon A, now what is self loop here? Self loop means upon reading zero or more number of A's, I am reaching the same state Q1. Okay, I am reaching the same state Q1. So now I am reading 1A, then whether I read 1A, 0A's or 10A's, anything, it is in the same state Q1. That means, let us say I am taking one example. I am reading, let's say, A, A. 2A's is my string. Okay, so for the first A, it is beginning with start state. So it goes here. It is upon reading A, it will reach the final state like this. Okay, so 1A is read. Now what is the other symbol we have is A. So I can use a self loop like this. Now, which is my state? Q1, which is the final state. So final state means the string is accepted. So A is accepted. Okay. Now let's come to one more example. Let me give A, B. I will give A, B. So it reads A, fine. It is reached the it has reached the final state. But what about B? Do you have any B here? That means what? It is not. There is no B at all here. So what happens is it is rejected. Okay, the string is rejected here. Okay, so this is how we complete the DFSM. So once you complete the DFSM, you need to write down all the tuple values. That is, you know, it is DFSM. So M is equal to 5 tuple machine it is. So it is having 5 tuples: K, sigma, delta, S and A. So K is nothing but set of all the finite states. So according to the design, we have two final states, Q naught and Q1. Then sigma is the input alphabet. So according to the question, we have just one A here. Okay, A is the input alphabet. Now what is S? Start state. So which is the start state? Q naught. Then A is the accept state or the final state. So the final state, just a review, you should be knowing that it is a recap. I can have any number of final states. I can have one or more final states. So that is why we put it as a set here. So what is which is the final state we have? That is Q1. Okay, now once you are done with writing the tuples, you have anyway drawn the transition diagram, and then you need to draw the transition table. So how do you draw the transition table? You have to have delta as the first column. That means all the states one by one you will be writing down all the states, and all the next columns will have input symbols. Okay, as such, in this question we have only one input symbol, so A will be the input symbol. So write down all the states one by one. Which is the first state we have? That is Q naught. Since it is a start state, we put an arrow mark here. We indicated it as a start state. And which is and the next state is Q1. So is this a final state? Yes, it is a final state. So we put a star symbol here. Okay. So now let us just check out what is the transition or how the transitions are happening. So what is Q naught upon A? It is reaching Q1. So Q naught upon A reaching Q1. What is Q1 upon A? It is still Q1 itself. So this will be your transition table. So whenever a question is asked like this, you will have to write the steps, write the skeleton diagram, then complete it, then write what is M, all the tuple values you have to write, and then anyway this transition diagram you must have drawn, and also you have to draw the transition table. Okay, I hope it is clear, and let us just try with the next question. Okay, so the second question is, draw a DFSM to accept strings of A's and B's having at least one A. Okay, now look at the difference between the previous example and this example. In the previous example, we had to accept strings of A's. That means my input alphabet was only A. In this question, my input alphabets are A and B. Okay, so my input alphabets are A and B, and then I have to have strings having at least one A. Okay, so let us see some. Okay, yeah, the steps are these. You know what are the steps? Let us see some valid strings and invalid strings. So valid strings. So according to this one, what is the minimum string I have? At least one A. So I should have minimum one A. So this is my minimum string. Okay. Now, according to the question, I can have strings having both A's and B's, right? So this is my second example where I have B and followed by any number of A's. That means I can have any number of A's. Minimum one A if I have, that means the string is accepted. Okay. Now let us see the third example. I have so many A's followed by so many B's. Am I having at least one A? Yes. Okay, the string is valid. Now let us see one more thing. I have so many B's followed by one A. So am I having at least one A? Yes, I'm having one A. That means it is a valid string. Okay. Let's see some of the invalid examples. B. Do you know why B is an invalid string here? Because it is not having at least one A. So it is invalid. Now the next example, capital B, BB. Again, this is invalid because there is no A at all. Now ABC, though I have A, it is capital letter. It is uppercase letter A. So there is no lowercase letter A in this. So it is invalid. Now fourth example, epsilon. Okay. Again, this is an invalid example because I should have minimum one A. Okay. So let's see the procedure. You know what is a minimum string accordingly. I have A as a minimum string. So input alphabets, sigma will be now A and B. A comma B you write. Okay. Now we will draw the skeleton DFSM. So skeleton DFSM, which is very similar to the previous example. I have start state. Upon reading A, it has moved to the next state. Okay. Final state. So I have read one A, done. Okay. Now The next thing is, fourth step is you have to identify what are the transitions which are not there in step 3. So this is the skeleton diagram you have. Yeah, according to the definition of DFSM, we should have transition upon every input symbol, upon every, no, for each state. So let me take first one, Q naught. What is Q naught upon A? We have to know. What is Q naught upon B? We should know. Similarly, what is Q1 upon A? We should know. Similarly, Q1 upon B? We should know. So you can also write it like this. I can write it like Q naught, Q naught upon A, upon B. What is happening? Upon A, upon A. Similarly, Q1 upon A, upon B, what is happening? So these are the things what we need to find out, and the same thing I've just written here. So now let us see how we can arrive at this. Okay, we have to complete the DFSM, that is the fifth step. Now the analysis comes. Okay, so let us just draw the DFSM again now, the skeleton DFSM. Now let us check one by one. First, let us go with Q naught now. Okay, now what are the two inputs I have? A and B. So Q naught upon A is done. Fine. Now what is Q naught upon B? That we have to find out. So now I think I have told you that how we have to go with the order. Okay. So let me just write down what are the orders you have to go with. So how do we know, what order we should go and find out those transitions is, first one, we should know that we have to always try putting a self loop. Okay. Try putting a self loop. Okay, if at all the self loop does not work, then you try with the forward transition. Okay, forward transition. Okay, if at all this is also not working, then we need to go with the backward transition. That is, backward direction arrow. So back transition. So this is how this order you need to go know, guys, all of you. Okay, we should know these are this order. Okay, first you try with self loop, otherwise go with forward transition, otherwise go with backward transition. If any of these cases is not satisfied, then we have something known as trap state or dead state. Okay, or dead state. That means it has to move to one state, and this state, what happens is it will not reach. I mean, like, it becomes infinite. Okay, if at all it reaches this state. Okay, so let us see each one in detail. Okay, so let me just try out making the analysis now. So Q naught upon A is done. Now, what is Q naught upon B? Can we have any number of zero or more number of B's at the beginning? Can we have? Yes, definitely we can have. Okay, because according to the question they have given, you should have at least one A. I can have any number of B's. There is no restriction upon B, right? So I can have B as a self loop. It is self loop means zero or more number of B's. Okay, so now after this, I need to check out what is Q1 upon A and what is Q1 upon B. So what is Q1 upon A? Let us try with self loop. Can we have Q1 upon A as a self loop? Okay. Can we have zero or more number of A's? Fine, very much possible. Okay. Similarly, can we have more one or zero or more number of B's at the end? Possible, very much possible. Okay. So we can have a self loop which is having A or B as the input. Okay, so this is like you have to come, this is how we are completing the DFSC. Okay, so let us just take a small example and then we will try to figure it out. So let me give example A, B, B. Okay, so let us see whether this string is accepted or not. So A. So what is A? From Q naught. Let us start with Q naught. So it will read A and then it will reach the final state Q1. Now what is the next letter I have? Next symbol B. So can I read B like this? Yes, it is either A or B. Okay, A comma B means A or B. So it has reached the final state. Now this is done. This is done. What is the next input symbol? B. Okay, can I read B again? Yes, very much possible. I can again read B. So which is my final state? Q1. Okay, and my string is read and I am in the final state. So the string is accepted here. Okay, so this is how we will do the analysis. Now after this, we have to write down what is M. So K, what is K here? Q0, Q1. See, input symbol will be AB. Start state is Q0. Accepting state is Q1. And then you have to draw the transition table. Okay. I hope you have got this point right. Okay. Thank you.